And this is going to be an example of how to do a chi-square goodness of fit test. So here is our example problem. A particular car manufacturer has believed for several years that among buyers of a particular type of sports car, 40% prefer red, 30% prefer green, 20% prefer yellow, and 10% prefer white. However, in a random sample of 252 buyers, they find that 114 actually preferred red, 57 green, 42 yellow, and 39 white. We're going to do a test to see whether or not this is true, whether the manufacturer is correct in their assumptions. So this is a chi-square test, so we're going to set up our phantom. So we're going to do our parameter. Well, our parameter is going to be in our observed, which we're going to put into our calculator in list 1. We had 114 red, so red was 114, green was 57, yellow was 42, and white was 39. Our expected then, that's going to go into list 2. We're going to do our percentages, so 0.4 times 252. And here we're going to do 0.3 times 252. And then we're going to do 0.2 times 252. And then we're going to do 0.1 times 252. These are the expecteds for 252 buyers. Our degree of freedom, since there's 4 categories, our degree of freedom will be 3. Our null hypothesis is going to be that the percentages of colors of cars are colors of cars sold are exactly what the manufacturer believes. And the alternate hypothesis would be the percentages of colors of cars sold are not what the manufacturer believes. Now you should write that out. I'm just being a little lazy because I don't have enough room here. Our assumption, since this is a chi-square test, the first assumption is we are given a simple random sample of buyers. And our next one is all expected counts are greater than or equal to 5. Now if I'm going to make that statement, I should actually back that up by showing what it is. So I go to my stat and my stat menu, edit. In list 1 over here, you can see that I put in my observed, and here's in list 2, and I did these multiplications that you can see up here. So therefore, I can go back into my test, and I can actually write down, so my expected values, we had red was 100.8, green 75.6. That was red, sorry, red. No, green, that was right the first time. Yellow was 50.4. And then white 25.2. So sure enough, all of them are above 5. The name of this test is a chi-square goodness of fit test. And now we're ready for our test statistic. So our test statistic is going to be chi-square which is going to equal, it's the observed minus the expected, so it would be 114 minus 100.8 squared divided by 100.8 plus, and then the next one was 57 minus 75.6 squared over 75.6 plus dot 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 dot. Now from here I'm not going to continue that list. Instead I'm going to go to my stat menu. So second quit. Stat menu, go over to test. I'm going to go to chi-square goodness of fit test, letter D, enter. I put my observed in list 1 and my expected in list 2 with a degree of freedom of 3, and then I'm going to calculate it. So based off of that, you can see that my chi-square value is 15.26, and that then has a p-value of 0.0016. So we need to make a conclusion. Our conclusion will be, since our p-value is so small, we reject the null. There is strong evidence to conclude that the color distribution of sold cars is not what the manufacturer believes. And that's it. That's how you do a complete chi-square test. So hopefully that helped, and you're now ready to do some of these. Come back next time for the other two types of chi-square tests.